Hello everyone, how are you? In today's lecture, we will discuss the standard integration techniques. Now students, as you know, we have already done the linear equation, Bernoulli equation, homogeneous, exact and Riccati equations, and we have learned the methods of solving these equations. Like we can solve the linear equation by using the integrating factor method. But now our task is to show that these equations are invariant under some infinitesimal transformations. Now students, you know, every linear equation is not separable, but every separable equation is linear. Okay, now if we just check the invariance of these equations under some infinitesimal transformations, then definitely after the change of variables, like definitely if they are invariant under some infinitesimal transformation, then we can find out the infinitesimals, and by using those infinitesimals we can find the change of variables, like we can find r and s, and then by using those r and s we can convert our given ordinary differential equation into a separable equation. And solving a separable equation is an easy task. Okay, now we are given the linear equation. The general form of a linear ordinary differential equation is given by this one. Now students, if you want to show the invariance of under the Lie group, this is the Lie group that is given to you. Okay, so you should learn it, that x bar is equal to x and y bar is equal to y plus epsilon e raised to power integral p of x d of x. Now students, if you want to check the invariance of this equation, then definitely when we are done with the least invariance condition, then we know we can write our given differential equation in this form. Now if I take all the terms on the right hand side, then I can write it definitely if you want to check the invariance, then you have to write it in a bar form. Okay, that means dy bar by dx bar is equal to q of x bar and minus p of x bar and y bar. Now x bar is equal to x, and on the left hand side we want to find dy bar is divided by dx bar. So dx bar means if we take the differential on both sides, we will get dx, and in the similar way if we take the differential of y bar, then it will become equal to dy plus epsilon it is per integral p of x dx, and after that the derivative of a power and integration and differentiation are opposite of each other, so they will be cancelled out with each other and we will get minus p of x. Now similarly we want to find dy bar by dx bar, and if we divide this term with the dx bar, then we will get this one. Now have a look over here, that if we want to check the invariance of this equation, then we can write it in this way, and after that we will substitute the values. That means dy bar over dx bar will be like here I have done dy bar is divided by dx bar. You can substitute the values simply here, so it will become plus epsilon minus p of x into e raised to power minus integral p of x dx plus px bar, and x bar is simply x, so we'll just substitute p of x into y bar, and the value of y bar is given by this one, so we have used it over here, is equals to q of x bar, and x bar is again x, so it will be the same. Now students, if we expand equation 2.55, then definitely here we will get the negative of epsilon p of x e raised to power integral p of x dx, and here we will get the positive of this term, so these two terms will be cancelled out with each other, and the remaining answer will be this one. And this is exactly the same equation that we have already written down, that is a linear first order ordinary differential equation, and in this way we can show that this equation is invariant under this Lie group. Now students, this is a one way of doing this problem, like to show the invariance. You can also use the least invariance condition that we have derived earlier in the previous lectures, and if you just find the infinitesimals by using x bar and y bar and substitute it over there, means in the least invariance condition, and if that condition is satisfied, then you can also show that this is linear ODE is invariant. Okay, means definitely if least invariance condition is satisfied, then obviously our original ordinary differential equation should be invariant. Now students, our next task is to find the change of variables. Now what is the benefit of change of variables? If we will be able to find the values of r and s, then we can convert our linear ODE into a separable equation, and that will be easily solvable. Now students, from the Lie group that is given to you, we obtain the infinitesimals capital X is equal to 0 and capital Y is equals to this one. Now students, what is the formula of finding capital X and capital Y? You know that in the previous videos I have derived the infinitesimals, like the infinitesimal, by using the infinitesimal transformations, and the formula was something like this. Partial x bar is divided by partial epsilon is equal to capital X of x bar y bar, and partial y bar is divided by partial epsilon is equal to capital Y of x bar and y bar. And the condition over here is that at epsilon is equal to 0, x bar is equal to x and y bar is equals to y. Now students, if you want to find, like here we are given x bar is equals to x, okay. Now if you want to find the value of capital X, then definitely you should take the partial derivative of x bar with respect to epsilon, and obviously it will become equal to 0, because with respect to epsilon it will be treated as a constant. But the condition is that at epsilon is equal to 0, like partial x bar by partial epsilon at epsilon is equal to 0, will be equal to definitely 0, because here we don't have any value, and if we have here any value in terms of x bar and y bar, then we will just replace it by x and y. Now in this way we will get capital X is equal to 0. In the similar way, students, you can find the value of capital Y. Now students, you know the transformation formulas for like R and S, and that are given by basically capital X of R of x plus capital Y of Ry is equal to 0, and capital X of Sx plus capital Y of Sy is equal to 1. Now definitely here x will be 0, so you will just substitute the value of y over here, and that is given by equation number 2.56. Thus definitely if you take this term on the right hand side, it will become 0, and if you integrate it, then we will get the r in terms of function of x, okay, some arbitrary function of x. In the similar way we can solve for Sy. Now rs and sx are arbitrary functions, and if we choose the value of r is equal to x and s is equal to 0, then you will get x is equal to r and y is equal to e raised to power minus integral p of r dr into s. Now students, our next task is to find the value of dy by dx, because when you find the value of x and y in terms of canonical variables, then definitely you have to convert your original ordinary differential equation in terms of r and s, because that equation then would be a separable equation. So students, if you find the value of dy, means you should take the differential of y and then the differential of x, then you will get this value, okay. And if you substitute it into the original equation and simplify it further, then the answer will be ds by dr is equal to e raised to power integral pr dr into q of r, and that is a separable equation. Now student, this is the general way of doing it. Let's have a look over a particular example and see that this it is an easy task to solve the first order linear equation. Now student, the question is y prime plus y is equal to x. Here definitely p of x is the value that is with the y, and here we have just 1, so p of x is equal to 1. Now capital Y will be equal to actually students, capital Y is this value, e raised to power minus integral p of x d of x, so it is equals to e raised to power minus x, because here definitely our capital X is equal to 0. Now we need to solve these two equations that are also given by equation 2.56, and if we simplify it further, then we will get the value of r is in terms of r of x, and s is equal to this one. So if we take r of x as equal to x and s of x 0, then we will get r and s in this way. And now the students, the task is, here it is equal to r is equal to x. Now if we take the differential dr is definitely equal to dx, and s is equal to e raised to power x into y, okay. Now first of all we can also write like this way, s is equal to e raised to power x y, and the value of x is equal to r, so you can also write s is equal to e raised to power ry, and the value of y will be equal to e raised to power minus s into e raised to power minus r. Now students, if you now take the differential of y, then after some simplification you will get this value, and obviously this is a separable equation, and you can also write it in this way, like ds by dr is equal to r e raised to power r, and ds is equal to r e raised to power r into dr. And if you integrate on both sides and simplify it further, then you will get your required answer. And if you after that, if you want to convert it in the form in terms of x and y, then you can just replace the values of r and s, and you will get your answer. And that will be a solution of your linear equation that is given in 2.53, or more precisely we can say in 2.57. Now students, I hope you understand this, and if you have any question, then you can also ask me in the comments. And thank you so much.